An electroscope is a scientific instrument used for detecting and measuring electric charge. It is a simple and ancient device that provides a visual indication of the presence and magnitude of electric charge, particularly static electricity. Electroscopes are often used in educational settings and research laboratories to demonstrate electrostatic principles. The basic components of a simple electroscope include metal foil. Most electroscope designs feature a pair of thin metal leaves or foil strips. These are typically made of lightweight and conductive materials like aluminum or gold. Metal rod. A metal rod or stem is attached to the top of the metal leaves. This rod can be made of metal or another conductive material. Enclosure. The leaves and rod are usually enclosed in a glass or plastic container to protect them from drafts and dust. Grounding connection. Electroscopes often have a grounding connection, such as a metal tab or a metal plate, that can be touched or connected to a grounded object to neutralize the electroscope. The working principle of an electroscope is based on the principle of electric induction. When an electrified object, charged with static electricity, is brought into proximity with the metal rod of the electroscope, it induces the movement of electric charges in the metal leaves. Like charges repel each other, so if the electroscope's leaves are initially neutral, they will separate when exposed to a charged object due to the repulsion between the charges. An electroscope can be used to detect the presence of electric charge in an object and determine divergence of the leaves, the higher the charge on the object. Electroscopes can also be used to demonstrate principles of electrostatic induction and conductive materials, making them valuable tools for educational purposes and scientific experiments. When you bring a negatively charged object near an electroscope, such as a negatively charged plastic rod or a negatively charged balloon, the following happens. Induction. The negatively charged object will induce the movement of electrons in the metal leaves of the electroscope. Electrons in the metal leaves will be repelled by the like negative charge on the object, causing them to move away from the object. Repulsion. As the negatively charged electrons in the metal leaves move away from the object, the metal leaves themselves become negatively charged. Since like charges repel each other, the metal leaves will repel each other, causing them to separate or diverge. Visible deflection. The separation or divergence of the metal leaves is a visible indicator of the presence of an electric charge. The greater the divergence, the stronger the charge on the object brought near the electroscope. When you bring a positively charged object near an electroscope, such as a positively charged glass rod or a positively charged plastic object, the following happens. Induction. The positively charged object will induce the movement of electrons in the metal leaves of the electroscope. Electrons in the metal leaves will be attracted by the positively charged object, causing them to move towards the object. Repulsion. As the electrons in the metal leaves move away from the positively charged object, the metal leaves themselves become positively charged. Since like charges repel each other, the positively charged metal leaves will repel each other, causing them to separate or diverge. Visible deflection. The separation or divergence of the metal leaves is a visible indicator of the presence of an electric charge. The greater the divergence, the stronger the charge on the object brought near the electroscope.